Imagine this. You step outside your spacecraft, no helmet, no suit, and take a deep breath of space. The vast cosmos fills your lungs just like the morning air back on Earth. Sounds impossible, right? Well, today we're diving headfirst into one of the most mind-bending what-if scenarios imaginable. What if humans could actually breathe in space? Now, before we get started, let's be clear about what we're imagining here. We're not just talking about holding our breath longer or having better lung capacity. We're talking about a fundamental change in human biology that would allow us to extract oxygen directly from the vacuum of space itself, or perhaps our bodies could function without oxygen entirely. It's a complete reimagining of how human physiology works. To really understand the implications of this scenario, we first need to grasp just how hostile space actually is to human life. Space isn't just an empty void lacking air. It's an environment so fundamentally different from Earth that it challenges every aspect of how our bodies function. The vacuum of space doesn't just mean no oxygen. It means no pressure, no protection from radiation, and temperatures that swing from hundreds of degrees below freezing to scorching hot depending on whether you're in sunlight or shadow. But let's suspend our disbelief and imagine that through some biological miracle, maybe evolution, genetic engineering, or alien intervention, humans developed the ability to survive and breathe in space. What would this mean for our species? How would it change everything we know about exploration, colonization, and our place in the universe? The first and most obvious change would be in space exploration itself. Think about how much of our current space technology is dedicated to just keeping humans alive. The International Space Station, for instance, is essentially a life support system with some scientific equipment attached. Massive portions of every spacecraft are devoted to atmosphere control, pressure regulation, and life support systems. If humans could breathe in space, we could throw out the rulebook entirely. Spacecraft could be dramatically smaller, lighter, and cheaper. Instead of these massive, complex vessels designed to create little bubbles of Earth-like conditions, we could have sleek, minimalist ships focused purely on propulsion and navigation. Think of the difference between a submarine and a speedboat. That's the kind of transformation we're talking about. But wait, there's more to consider. Even if we could breathe in space, we'd still face other challenges. Temperature, for instance, would still be a major issue. Space is cold. Really cold. We're talking about temperatures around minus 270 degrees Celsius in the shadowed areas. Even with the ability to breathe, we'd still need some form of thermal protection. But maybe, in our hypothetical scenario, our space-breathing humans also evolved better temperature regulation or even the ability to hibernate during long journeys. And what about radiation? Space is flooded with cosmic rays and solar radiation that would cook an unprotected human in short order. Our atmosphere and magnetic field protect us from most of this on Earth, but in space, it's a constant deadly presence. Perhaps our space-breathing humans also developed tougher skin, enhanced DNA repair mechanisms, or even the ability to absorb and process radiation as an energy source. Imagine that, humans powered by starlight and cosmic rays. Now, let's talk about the mechanics of how this space-breathing might work. There are several possibilities we could explore. Maybe humans evolved specialized organs that could extract trace particles from the solar wind, those charged particles constantly streaming from the sun. Or perhaps we developed the ability to break down and utilize the scattered hydrogen atoms that do exist in space, sparse as they are. Another possibility is that we evolved beyond the need for traditional respiration entirely. Maybe our space-adapted bodies learned to derive energy directly from electromagnetic radiation like plants do with photosynthesis, but on steroids. We could be living solar panels, absorbing energy from stars and converting it directly into usable biological fuel. Or, here's a wild thought. What if we developed a symbiotic relationship with microscopic organisms that could survive in space? These tiny partners could handle the actual breathing for us, processing whatever materials are available in space and providing us with the energy we need. We'd be walking ecosystems, carrying our own personal space processing plants. The implications for space travel would be staggering. Journey times that are currently limited by life support could extend indefinitely. A trip to Mars, which currently requires careful planning around launch windows and life support capacity, could become as casual as a road trip. Why stop at Mars? Jupiter, Saturn, even the outer reaches of our solar system could become accessible with relatively simple spacecraft. But let's think bigger. Interstellar travel, journeys to other star systems, suddenly becomes a realistic possibility. Right now, the biggest challenges to interstellar travel are the enormous distances involved and keeping humans alive for decades or centuries. But if humans could survive indefinitely in space without complex life support, we could actually consider generation ships or very long duration missions. Picture this: a crew of space breathing humans embarking on a century long journey to Proxima Centauri, our nearest stellar neighbor. They wouldn't need massive hydroponic bays, air recycling systems, or complex rotating sections to create artificial gravity. They could travel in relatively small, efficient ships, maybe even taking spacewalks during the journey to perform maintenance or simply enjoy the view. This brings up an interesting point about gravity. Without the need for pressurized environments, we might not need to create artificial gravity through rotation. Our space breathing humans might be perfectly comfortable living in zero gravity permanently. This could lead to some fascinating evolutionary adaptations over time. Longer, more flexible bodies adapted for three-dimensional movement, enhanced spatial awareness, maybe even new organs specialized for navigating in zero-G. Now let's consider what this would mean for space colonization. Currently, establishing permanent human settlements in space requires creating artificial, Earth-like environments, pressurized habitats with controlled atmospheres. It's incredibly challenging and expensive. But space-breathing humans could colonize space in ways that seem like pure science fiction today. Asteroid mining, for instance, would become trivially easy. Workers could operate directly on asteroid surfaces without the need for pressurized equipment or enclosed mining facilities. They could work with simple tools, maybe just wearing basic temperature regulation suits. The entire asteroid belt could become humanity's industrial heartland, with workers hopping from asteroid to asteroid like island hopping in the Pacific. Space-based manufacturing would explode in possibilities. Without the need for enclosed, pressurized facilities, we could build massive industrial complexes in space, using nothing but basic structural materials. Imagine factories the size of cities, constructed from processed asteroid metal, producing everything from spacecraft to consumer goods in the perfect vacuum and zero gravity of space. The economic implications would be revolutionary. The cost of doing anything in space would plummet. Currently, every single component that goes into space has to be designed to function in a sealed, pressurized environment, which adds enormous complexity and cost. Remove that requirement, and space operations could become remarkably affordable. But let's think about the social and cultural implications, too. How would human society change if we could truly live in space? For one thing, the concept of nations and borders becomes pretty meaningless when your species can survive in the infinite vacuum of space. Territorial disputes over land would seem quaint when there's literally unlimited space available. We might see the emergence of truly nomadic human cultures, groups that spend their entire lives traveling through space, never settling on any planet or in any fixed habitat. They could follow interesting astronomical phenomena like comets or asteroid swarms, or simply explore for the joy of discovery. Imagine families that have been traveling between star systems for generations, with their own unique cultures and traditions, adapted for life in the void. The relationship between humans and planets would fundamentally change too. Planets, instead of being essential for human survival, would become optional destinations. We might choose to visit planets for their unique features: the storms of Jupiter, the rings of Saturn, the geysers of Europa, but we wouldn't need them for survival. This could actually be better for planetary preservation, as we wouldn't need to terraform or heavily modify worlds to make them habitable. Think about how this would change our perspective on Earth. Right now, Earth is our lifeline, the only known place in the universe where humans can survive naturally. It's irreplaceable. But if humans could survive anywhere in space, Earth becomes just one beautiful world among many. This might lead to better environmental protection. Earth could be preserved as a kind of natural park or museum, while the bulk of human industry moves into space. Or it might lead to the opposite. Humans might become so adapted to space life that returning to planetary surfaces becomes uncomfortable or even impossible. We could see a branching of human evolution, with Earthbound and space-adapted humans becoming distinct subspecies over time. The implications for science and discovery would be enormous, too. Currently, our ability to study space is limited by our need to send robotic probes or very expensive, carefully planned human missions. But space-breathing humans could explore personally and extensively. Instead of waiting years for data from a Mars rover, we could have teams of scientists working directly on the Martian surface. in the atmosphere of Venus or on the moons of the outer planets. Imagine the discoveries we could make. We could have permanent research stations in the rings of Saturn, studying their composition and dynamics up close. We could have teams of geologists working in the asteroid belt, uncovering the secrets of the solar system's formation. We could establish observatories in the outer solar system, far from the interference of Earth's atmosphere and radio emissions, potentially detecting signs of life around other stars. The search for extraterrestrial life would be completely transformed. Instead of relying on radio telescopes and space probes, we could literally travel to other star systems and investigate potentially habitable worlds directly. If we found evidence of life or actual living organisms, we could study them in their natural environments rather than trying to analyze them from billions of miles away. But this brings up an interesting question. What if we're not the only species that can survive in space? Our space-breathing humans might encounter other space-adapted life forms. Perhaps there are entire ecosystems living in the void between stars, feeding on cosmic radiation and the sparse matter of interstellar space. We might discover that space isn't empty at all, but filled with life forms so different from terrestrial biology that we never knew how to look for them. The military implications would be fascinating and terrifying. Space warfare would take on completely new dimensions if humans could operate directly in the vacuum of space. Instead of massive, expensive spacecraft that are vulnerable to attack, military forces could consist of highly mobile individual soldiers operating with minimal equipment. Space battles might look more like aerial dogfights than the massive ship-to-ship engagements we see in science fiction, but maybe the ability to survive in space would actually make warfare less likely. When resources are essentially unlimited and there's infinite room for expansion, what would there be to fight over? Traditional causes of conflict, territory, resources, strategic positions, become meaningless when your species can survive anywhere and has access to the resources of the entire galaxy. Let's consider the timeline for all of this. How long would it take for space-breathing humans to spread throughout the galaxy? Even with faster, more efficient travel, the distances involved are staggering. Our galaxy is about 100,000 light-years across. Even if we could travel at a significant fraction of the speed of light, let's say 10%, it would still take 1,000,000 years to cross the galaxy. But maybe that's okay. If humans can survive indefinitely in space, time becomes less of a factor. A 1,000,000-year journey might not seem impossible if you know you and your descendants will survive to see the destination. We might see a slow but steady expansion of humanity throughout the galaxy, with each generation pushing a little further into the unknown. This raises questions about human identity and culture. How would human civilization maintain any kind of coherence across such vast distances and timescales? Groups of humans separated by thousands of light years would inevitably develop their own cultures, languages, and even evolutionary adaptations. After 1,000,000 years of separation, would they even still be recognizably human? We might see the emergence of a truly galactic civilization, but one that's incredibly diverse. Each star system or region of space might develop its own unique human culture, adapted to local conditions and opportunities. The humans living in the dense stellar nurseries near the galactic core might be completely different from those adapted to the sparse, cold regions of the galactic halo. Communication across such distances would be a massive challenge, too. Even at the speed of light, messages would take thousands of years to travel between distant human settlements. We might need to develop new forms of long-term cultural transmission, perhaps physical artifacts or even genetic memory systems that could preserve important information across millennia. But let's step back and think about the immediate implications again. What would the first generation of space-breathing humans do? Where would they go first? Mars seems like an obvious destination. It's close, we already know a lot about it, and it has some interesting features to explore. But without the constraints of life support, Mars becomes just a quick stop rather than a major undertaking. The asteroid belt might be more attractive. It's rich in resources, has thousands of interesting worlds to explore, and could serve as a perfect base for further expansion. Our space-breathing humans might establish their first permanent space civilizations among the asteroids, mining and processing materials to build even larger installations. Jupiter would be fascinating to explore. Its massive radiation belts would still be dangerous, but maybe our radiation-resistant space breathers could handle it. They could explore Jupiter's many moons directly, diving into Europa's subsurface oceans or studying the volcanic activity on Io up close. Saturn's rings would be like a playground for space-breathing humans. They could literally swim through the ring particles, studying their composition and dynamics from the inside. It would be like having the world's most spectacular ice rink, but one that stretches for hundreds of thousands of miles. The outer planets, Uranus and Neptune, are so far away that we've barely studied them. Space-breathing humans could change that, establishing research stations in these distant, mysterious worlds and finally solving some of the puzzles about their unusual properties and strange magnetic fields. But here's where things get really interesting. What lies beyond our solar system? Currently, we can barely detect planets around other stars, let alone study them in detail. But space-breathing humans could actually travel there and explore them directly. The closest star system, Alpha Centauri, could become humanity's first interstellar colony. And if there are habitable planets there, we can study them without the need for terraforming or enclosed habitats. We could explore alien biospheres directly, walking on alien surfaces and breathing alien atmospheres, sort of, since we wouldn't need to breathe them anyway. The psychological implications of all this would be enormous, too. How would human consciousness and identity change if we could survive in the infinite void of space? There's something profound about being surrounded by the cosmos with nothing but vacuum and starlight around you. It might lead to new forms of spirituality or philosophy based on our connection to the universe itself. We might develop a completely different relationship with time and space. When you can survive for centuries or millennia in space, and when the distances between destinations are measured in light years, your perspective on time would be fundamentally different from earthbound humans. Art and culture would evolve in fascinating ways too. Imagine sculptures carved from asteroids, visible from millions of miles away, or performance art that takes place across multiple star systems with acts that unfold over decades or centuries. Literature might evolve to tell stories that span galactic distances and geological timescales. But let's consider some of the potential downsides of this scenario. What if the ability to breathe in space came with unexpected consequences? Maybe space-breathing humans become addicted to the cosmic radiation or the solar wind. Maybe prolonged exposure to the vacuum of space causes psychological changes that we can't predict. There could be biological downsides, too. Maybe the adaptations that allow humans to survive in space make them vulnerable to other threats. Perhaps they become more susceptible to certain diseases, or their enhanced radiation resistance comes at the cost of reduced fertility or shortened lifespans. And what about the earthbound humans who don't have these adaptations? Would there be conflict between space breathing and traditional humans? Would the space breathers see themselves as a superior subspecies? Or would the earthbound humans view the space breathers as freaks or abominations? There could be economic disruption, too. If space-based industries become incredibly cheap and efficient, Earth-based economies might collapse. Traditional jobs and industries could become obsolete overnight. The social upheaval could be enormous. But despite these potential challenges, the opportunities would be incredible. Space-breathing humans could finally answer some of humanity's biggest questions. Are we alone in the universe? How common is life? Are there other intelligent species out there? With the ability to personally explore thousands of star systems, we could finally get definitive answers. We could also solve some of Earth's biggest problems: overpopulation, resource depletion, environmental degradation. All of these become manageable when you have the entire galaxy's resources available and unlimited room for expansion. Energy wouldn't be a concern either. Stars produce enormous amounts of energy, and space-breathing humans could harness it directly. They could build massive solar collectors around stars, capturing and redirecting stellar energy for human use. The concept of energy scarcity would become obsolete. Space-breathing humans could even engage in stellar engineering, modifying stars themselves to suit human purposes. They could extend the lives of dying stars, create new star systems, or even trigger the formation of new stars from nebular material. Humanity could become a true cosmic civilization, engineering the galaxy itself. The scientific implications are mind-boggling. We could conduct experiments on scales impossible on Earth. Want to study black hole physics? Set up a laboratory right at the event horizon. Interested in galaxy formation? Observe the process directly over millions of years. The entire universe becomes our laboratory. We could also preserve knowledge and culture on cosmic scales. Instead of worrying about the survival of human civilization on a single planet, we could distribute human knowledge and culture across thousands of star systems. Even if entire regions of space were destroyed by supernovae or other cosmic catastrophes, human civilization could survive elsewhere. But maybe the most profound implication is what this would mean for human consciousness and philosophy. When you can survive in the vacuum of space, surrounded by the infinite cosmos, you develop a truly cosmic perspective. The petty concerns of planetary life, politics, territorial disputes, resource competition, fade away when you're surrounded by the vastness of space. Humans might develop a completely new understanding of their place in the universe. Instead of being a tiny species clinging to a small planet, we'd be native citizens of the cosmos itself. The universe wouldn't be a hostile environment to be conquered, but our natural habitat. This could lead to new forms of consciousness and awareness that we can barely imagine today. When your natural environment is the infinite universe, your mind might expand to match. We could develop truly cosmic intelligence, capable of thinking on scales of space and time that dwarf anything possible for planetary life. And who knows, maybe this cosmic perspective would help us understand the universe itself better. Maybe space-breathing humans would discover fundamental truths about reality that are invisible to planet-bound observers. They might uncover the secrets of dark matter and dark energy, understand the true nature of time and space, or even discover whether our universe is just one of many. In the far future, space-breathing humans might not even be recognizably human anymore. After millions of years of evolution in space, they could become something entirely new, a truly cosmic species adapted for life among the stars. They might develop abilities we can't even imagine today: the power to hibernate for millions of years, the ability to sense gravitational waves directly, or even some form of faster-than-light travel or communication. They might even transcend physical form entirely, existing as patterns of information that can travel at the speed of light between star systems, experiencing the universe in ways that biological beings never could. But even in this far future scenario, they would still carry the essential spark of humanity: curiosity, creativity, the drive to explore and understand. These cosmic descendants would still be recognizably related to the humans walking around Earth today. So what can we learn from this thought experiment? Even though humans breathing in space is biologically impossible with current understanding, exploring this scenario helps us think about the fundamental constraints on human expansion and our relationship with the cosmos. It highlights how much of our current space technology is devoted simply to keeping humans alive, and how different things could be if we could overcome those biological limitations. It also makes us think about what it means to be human. Are we defined by our biology or by something deeper? Most importantly, it reminds us that the universe is vast and full of possibilities we can barely imagine. Whether through biological adaptation, technological enhancement, or some combination of both, humans might one day find ways to truly live among the stars. Until then, we'll have to content ourselves with our current methods of space exploration: robots, probes, and carefully planned human missions in protective spacecraft. But who knows? Maybe somewhere in our future, the impossible will become possible, and humans really will learn to breathe among the stars. The universe is waiting for us out there, vast and mysterious and full of wonders we haven't even begun to imagine. Whether we explore it in spacesuits or with cosmic lungs, the important thing is that we keep reaching for the stars. Because in the end, that's what makes us human: the irrepressible urge to explore, to discover, to push beyond the boundaries of what we think is possible. Thanks for joining me on this journey through one of the most incredible what-if scenarios imaginable. What do you think? If humans could breathe in space, where would you want to go first? The rings of Saturn, the moons of Jupiter, or would you set your sights on the stars themselves? Let me know in the comments below, and don't forget to subscribe for more mind-bending what-if scenarios that push the boundaries of imagination and possibility.